Thank you, Marcus. And just to correct it, Marcus, my name is spelled with a K, the correct version, right? So I don't know about you guys, but when I drove up here this morning to Murray Hill, I thought myself, is this real? Am I really at the place today where Unix was born, where some of these big pioneers that I always heard in college actually about will be here, and will I have the chance to talk to them? It was really a little bit surreal for me, and I had to pinch myself. And I know that a lot of my teammates and colleagues have the same feeling. And I invite yourself, all pinch yourself, pinch your neighbor, no, don't pinch your neighbors, but pinch yourself. It's real, you are here, and we are celebrating 50 years Unix with some of the pioneers here, and I think this is the highlight of my career so far. And we want to start off the day also with a big bang, right? Fitting. We start the day with a big bang, with a panel with some of the Unix pioneers about the origins of Unix. And before I reveal who will be on the panel, I want to tease you a little bit. I want to ask for your help to identify who the panel moderator will be. And I will give you some hints, and then as soon as you know who that panel moderator is, I invite you to shout out his name, all right? So first hint, hello world. Oh, you guys are, okay, good. So then the other tests, the other hints I had was, right, the term Unix, or awk, right? And of course, the C programming language. So Brian, of course, who in this room doesn't know Brian? Okay, no hardware guys here, all right, good, okay, good. So I apologize to my colleagues, all right? So, okay, Brian, of course, does really not need an introduction. He was at Bell Labs for over 30 years, is now at Princeton University. And rather than listing all the accomplishments and recognition he has gotten, I actually want to tell a little story how I first met Brian. And I'm sure, Brian, you will not remember. It was not the summer of '69, it was the summer of '89. This is when I, as a greenhorn, I just finished my PhD, had no clue about anything, had no plans about my career, just thought Bell Labs is a cool place, went there to stay for 1 year. Well, you know how that turned out. 20 years later, I'm still here. Went there for 1 year, and after just 2 or 3 weeks, I happened to be in a meeting here in Murray Hill where I was sitting next to a gentleman who looked really nice with a beard, and we got to talk a little bit, and it turned out he was from Canada, and I was from Germany, so we started bashing our US colleagues and made fun of them. And I immediately liked the guy, right? So, and he was always asking, Marcus, what are you working on? What do you do? And have you thought about this? And then I thought maybe I should ask the friendly person next to me also what he's working on. So I asked him, so what are you known for? And then I thought, when he flipped his notebook over and the name Brian Kernighan was there, I said, did I just ask Brian Kernighan what he's known for? So, but apparently this does not stop you making progress here at Bell Labs, so I'm still here. And so yeah, Brian is our moderator here. So Brian, I invite you up on stage. And also... Yeah, okay. And I also want to invite up the other panelists that Brian will introduce. These are, please come up here, Stephen Johnson, Jon Bentley, Doug McIlroy, and for the last one, I have been told I need to do this, Peter Weinberger, all right?
Okay, we are going to sit down. Yes. Marcus, thank you very much, however spelled, for those kind introductions. And I must say, speaking for myself, and I'm sure for everybody else, this is absolutely wonderful to be back here. I have many happy memories of this auditorium in particular, and also all kinds of Bell Labs. I did spend over 30 years here, had a great time with an infinite number of good colleagues, many of whom I see here. Some of you slightly more gray-haired than you used to be, but okay, that's all right. Okay, so it's absolutely wonderful, and I'm really grateful to the folks at Nokia Bell Labs for putting this event together after 50 years. It's a great deal. So the panel has an incredibly vague charter, the origin of Unix. Okay, so what we're going to do is talk about that, but we have here 4 people who actually know something about the topic, different things perhaps. And so what I'm going to do is ask each of them to talk for roughly 5 minutes on whatever they want to say about that. And then at the end, we get a chance to let you folks ask some questions, although I can't see anybody because the lights are too bright. And that's what we'll do. So, Doug McIlroy, who is there, the creator of any number of core tools that you've probably used if you've ever used Unix. And I think, in all seriousness, without whose technical and managerial excellence of judgment, Unix might not have happened. So Doug will be first. I guess second is Jon Bentley, who's an insightful critic of all kinds of things, on writing in particular, an expert on algorithms, a wonderful person for conveying the essence of important things through things like his Programming Pearls books, and a pollinator of ideas, the kind of person who wandered around talking from one person and then another, passing interesting and good ideas around. Steve Johnson on the far end, creator of language tools, without whom I would not have been able to do many of the things that I did. The creator of the portable C compiler that made it possible to move Unix to other hardware platforms, as Marcus with a C mentioned, including the port of Unix to the Interdata 832 that was done with Dennis Ritchie. And then finally, to my immediate right, Peter Weinberger is certainly the best known face in the group.
That's enough, isn't it?
With Alejo and Peter, we created awk in the late 1970s. Peter did remote file systems, database software, and he was, in fact, executive director of the area just before the great investiture of 1996. So all of us have lots of memories, lots of insights. None of these folks have ever been very shy about expressing their opinions, quite the contrary. So I'm just going to leave it to them to speak for themselves. Okay? So let's start with Doug.
Let me begin with a shout out for TUHS, the mailing list of the Unix Historical Society. Assuming that you're here because you're interested in Unix over all time, that's a place to go to just to keep up to date, and you'll find out much more interesting things that I can tell you about the history of Unix, because it extends worldwide. My assignment was to talk about how Unix came to be and versions and all that sort of stuff, but probably everybody knows all of that. It has been written about by Dennis Ritchie much better than I could. So I will just try to find a few incidents that illustrate what happened in the wonderful Unix room or rooms. Unix, of course, was born out of the ashes of Multics, which was the third big operating system that had been worked on here at Bell Labs. The other two had been written by never more than a handful of people. Multics was at least 80 people, 10 of whom came from Bell Labs, and stretched all the way across the country from Cambridge, Massachusetts to Phoenix, Arizona. And in 5 years didn't manage to produce a working operating system. But it did produce some good ideas, and some people in the back room, notably Ken Dennis and Rudd Canaday, were thinking about how they might be able to do it better with a little bit less of a design effort. Multics had a 5-foot shelf. At one point, when folks in AT&T IT department were wanting to buy a VAX, they commissioned a professor at Harvard, who obviously was very good at getting such commissions, to tell why it would be better to use DEC's operating system than our operating system. And his response essentially was, well, DEX is made by mature operating system developers. And furthermore, its shelf of manuals is, a measure of this maturity is its shelf of manuals is 2 feet long. and Unix's is only 2 inches. That apparently pleased the folks at AT&T headquarters, all except for the president's office. The president's office had a different idea. Charlie Brown was a little bit vain about appearing in public wearing glasses. And his PR people heard that we had a photo typesetter and wondered, could we set type for Charlie Brown's speeches in large type? Well, sure, we could do that. And it doesn't hurt. For the little extra effort it would cost us, we would have an in the CEO's office. So we did it. Various adventures happened, such as once when Charlie was a little late with his speech planning. They sent out a helicopter to land on Bell Labs' lawn and take our printout back.
I do remember that.
Another time, I found that they had decided that the access to our machine was good for something other than speech writing, and were maintaining the minutes of the AT&T board on our computer, a computer where everybody had super user privilege, and probably the most visible computer available by dial-up in the world. Fortunately, the minutes are very non-committal. Wise plan. You don't know what they talked about. All you know is what they decided. Anyway, I did call the PR vice president and say, I think it would be a good idea if you got the board minutes off our machine. And consequently, a special Unix was installed in the CEO's office. Not bad. There were several themes that prevailed in the Unix room. By the way, cut me off at any time.
I'm not keeping score here. I have no idea.
One is text processing. When Joe Osana, Ken Thompson in particular, were searching for a new computer to do operating system research on, higher management said, we were burned on Multics. It's not a good idea. They suggested PDP-10s from DEC as a cheaper, but still expensive and mainframe kind of machine. Finally, when the PDP-11 came out, brilliant idea. The fig leaf is that we'll make a word processing system that can be used in Bell Labs typing pools and secretaries' offices. But to do that, we can't build that unless we have our own operating system. We'll use that to create a word processing system. That plus a little help from our friends in visual and acoustics research who had some spare money at the end of the year, bought a PDP-11. And from there on, it's history. But text processing was to be a theme through the whole life of the Unix lab. And notably, the phototypesetter, we've already told one story about it. When the phototypesetter appeared, there was an explosion of people making the most gorgeous and creative outputs. Fortunately, Mike Lesk came along later on and said, let's make good-looking outputs all the same, the MS facility. And the creativity stopped, and it was a good idea. But the first manuscript that was sent out of that laboratory resulted in a response from the publisher. Are you sure, from the journal, are you sure this hasn't been published somewhere else already? Yes, we were sure.
Hey, Doug, should we pause temporarily and move on to someone else for?
That's fine.
Okay, yeah. Okay, I think John was next in the rotation.
Doug began with his shout out to the Unix Historical Society. I'll give my shout out to a wonderful new book. You can grep for it at Amazon if you grep for Kernighan Unix Memoir. I've spent much of the last summer reading various versions of it. It was a great way to page back in those things. Allegedly, my copy should be arriving this afternoon. They are hot off the press. You too should get some. And in addition to my shout out, I will give my curse to the same young Brian Kernighan who placed me after Doug McIlroy, the very worst place to be in any speaking order. My task was to talk about the Unix community. It flourished in many parts of Building 2. The Holy of Holies was, of course, the Unix room, but even more important for many people was the lunch table. The Unix room denizens left promptly at 1 for their lunch table. The rest of us left around 11 o'clock for ours. Sometimes we would join 1138 at 11:30. The math people had theirs at 12. Sometimes we had chemists, we had physicists, outside developers come here. That was a big part of the community. After the lunch table, we had a walk. On nice days like this, there used to be wonderful berries around the back of the building. Alejo, in addition to many things, is a marvelous berry picker. That he knew where all the great berries were. Delightful walks. All topics were fair game. Early ideas for a new theorem, questions about a program, interesting new technical paper, local dining, politics, anything. The lunch table was where many of us had the biggest slice of our Unix community. Brian mentioned that I wrote a book and columns called Programming Pearls. I did that precisely because there were software gems scattered throughout 1127 and Bell Labs, and the community delighted in sharing them. Ken Thompson's chess game analysis, Doug McIlroy's spell checker, Bob Morris's tiny counters, Norm Schreier's floating point tests, Vit Visosky's memos on software, Rob Pike and Bart Lucanthi's wicked fast BitBlit, John Linderman's sort, the list goes on and on. After I had stolen a good idea came the very hard work of putting it into writing. Looking back, one can view Center 1127 as a writing school that did a little programming on the side. Every piece that I wrote was torn to shreds and then reassembled by 1127 colleagues. Comments range from subtle bugs and errant words to suggestions for completely rebuilding text and code. I learned to write from people on this stage, especially Doug McIlroy, and from others, including Alejo, Dennis Ritchie, Ravi Sethi, and David Johnson. 50 years have passed. The friendships remain. It's great to be back here as part of the Unix community and the Bell Labs community. Thanks for having us.
Steve.
Well, I just remember the time working with these folks is an extremely happy time. You know, you never knew what was going to happen when you walked into the Unix room, but it was always good. And it was also a time when I had 2 kids at home, aged 1 and 3, so I was sleep deprived, and I got a terminal at home. It was incredibly wonderful. Now, of course, I had to haul a box of fanfold paper home about every 2 weeks, and occasionally we had some glitches, such as the time the cat decided to use the fanfold box as a litter box. But it was just remarkable. And the sense of working on something that was going to be, wouldn't really come to fruition for 5 or 10 years was quite exhilarating. I think we all believed that. But day to day, it was just wonderful. I came to the Unix group a little bit differently than other folks. I actually had been an intern for three summers before coming to work permanently. And I was in the Human Information Processing division and wrote papers on cluster analysis and that kind of thing. But I also used the computer a lot. And the computer center was hurting because it was being run by researchers. And a lot of the users were getting pretty irritated at the way that things weren't going as well as they could. And I've always believed that computer science is a service profession. And that if the customers, if you will, of what you're doing aren't happy, you have not succeeded. So I accepted a job helping to run the computer center. And this was actually somewhat encouraged by the fact that my previous organization had run out of computer money in October the previous year, and we were told to, quote, put our work on a firmer intellectual footing, okay, until January 1st. So I decided to go where the source of the cycles were. And that same impulse led me to leave the research group and go over to the development organization that was building System 5, partly because I knew we had these gold nuggets coming out of research, and they weren't going to get out if somebody didn't do that. And so I did. And so we produced the first commercial C++ compiler and completely rewrote the debugger, which meant that we could handle languages like Ada and what have you. And another aspect of the spread of Unix, which is what I think was very powerful, was the organization Unix. I ended up as the Bell Labs, if you will, representative on the Unix board, recommended by Dennis, actually, who wanted nothing to do with it. And the great thing about Unix in those days was that the conferences were roughly 50% industry and 50% academic. And that was just an incredibly rich environment. You know, so the problems people were having and the issues and the things they wanted were just face to face with the people who could address them. And Unix did a lot of wonderful things. We basically financed the first ISP, for example, and did a great deal to make system administration into a real discipline, as opposed to just somebody coming in and doing file dumps at 3 in the morning. I think I could go on for hours, but I won't.
Okay, Peter. Clean up hitter.
How much time do I have, more or less? I will watch. There's a countdown clock. I will pay no attention to it.
Oh.
So I was going to talk about what we got right and what we got wrong, and I have a sort of fairly technical discussion, but maybe I won't give all of it, because I realized that when I was thinking about it, I was in the mental state of, if it were 1985, knowing what I know now, what would I think we should be working on? What did I think we had gotten right? And it's not 1985, right? So maybe that's not exactly the right thing to talk about, but I'm going to give a couple of sort of what I think are technically significant things with a slightly historical slant. So one of the things that Unix got right, and everybody knows it, is thinking of files as just streams of bytes. And when you think about it nowadays, you say to yourself, well, what they were doing was there's files like this and files like that and files like this, and the lowest common denominator is bytes, so that's a good choice. That's not what was going on in 1969. In 1969, when you wrote disks or you wrote tapes, you decided what your record structure looked like, right? The IBM disks of those times, although you had to fit in one track, you might ask what's a track, but we don't care, is, right, you got to decide how long the records you wrote in that track were. So it's actually the idea of using a raw stream of bytes is an abstraction, and quite a valuable one. The other two things I'm going to mention briefly, since I've now slipped into what I wasn't going to do, is is fork and exec, which produces this unbounded tree of processes. Okay, I'm not saying it was original, but the idea that you have this unbounded collection, this unbounded evanescent tree of processors, is quite different from the way a lot of systems at that time ran, where there was some fixed collection of task slots that you sort of signed up for and put in. And if you have this giant tree, you need some form of inter-process communication. And the cleverness, I think, one of the clevernesses of people who made this decision, all of these decisions were made way before I got there, so it's okay, was to choose pipes, which are not the most general form of inter-process communication, but plenty useful. And I think the final thing I want to talk about on the good side is the hierarchical file system, which is so common now, it's hard to imagine what the alternatives were. But back on those 5-foot shelves of manuals, there were lots of alternatives, and none of them were particularly satisfactory. The interesting thing about having a large hierarchical file system is you got to name the stuff, okay? And then you need some kind of, for utility and for people to use at the command line, some kind of pattern matching story, right? And one of the things we never, I would say, got totally right is which form of pattern matching were we using where. I'd like to talk briefly about 2 things we got wrong. One thing we got wrong was networking, and I don't feel so bad about that because everyone's gotten that wrong. Okay, that's just, that to this day, things are not satisfactory. The other thing which I think with inhuman insight we might have done better on is configuration. So in the good old days, an application was essentially an executable somewhere. And a lot of the applications come with ancillary files, and some fraction of them come with per-user customization. And we had, I think, it was good idea, but should have changed to put stuff in dot files. So if you look in your login directory now, right, there's some terrific collection of anonymous dot files that you can't figure out whether you're using or not. Well, you can sort of figure out if you've used them recently, but that's not the same as whether or not you need them. And upgrading or removing applications was very difficult. For some of the configuration stuff, Microsoft faced the same problem and did the registry. Nice try, but no. Right? There's among other issues, there's a naming problem. Okay. The people who came closest to getting this right is Apple, who decided that an application was really a directory with a bunch of, so you could put all the ancillary stuff there, and some parallel structure local to you, so for your own configuration choices. But you can't fix the old unfortunate state, right? If you go to Linux or OS X and click on an icon, that command sees a different environment than your command line stuff that runs in the shell. You can make them the same. That's a challenge for those of you who have nothing to do today. So I think the number of things it's not we, that they got right in the early things is really quite remarkable. And I just wish we had seen the future more clearly. So,
Apropos of the early file systems, in the GCOS operating system, which was going on in 1969, and from which where the PDP-7 Unix tapes were prepared, there was one very telling command. It was called futile, spelled without an E. And that was the magic of file systems. It had 1,000 different options. Just mind-boggling.
I remember the futile command, yes. Do any members of this August group wish to comment or react to others, as Doug just did? Otherwise,
I didn't hear the question, sorry.
Any reaction?
Interaction?
Comment on any of the other.
right, the question is, did any of us get it wrong?
Yeah, I'm sorry.
no,
Yes, we all do.
I just didn't.
That's fine.
I'm happy to talk about the comm center, however, because that was one of the things that I did was to go, when I was in the comm center, was to join a users group. And I think I was about 19 maybe, or 20 at that point. And I went off to my first big business meeting, which was out somewhere in the Midwest. And this guy comes up to me from GE, it was then, and says, "Let me buy you a drink." Okay, and I'm like, what do I do with this? It was remarkable. I mean, at those days, the computers were $10 million, And they came with 2 or 3 employees of the computer company, okay? And our job was to suggest improvements. For example, when you turn the power on the computer, and it comes up and says init, question mark, okay? You should say no, because if you say yes, it will wipe out the entire file system. Okay. So we respectfully requested that they change that message to read, do you want to write all over the file system? And they did. The model of a central computation center was already beginning to look kind of difficult. I mean, it was not only the expense, but the monolithic nature of it. You really couldn't please more than a small fraction of the people that you needed to please. And I think that it was clear to me, certainly, that Unix was the future, that having smaller machines that could be specialized and be stocked with exactly what a particular group needed, and be this sort of environment to grow the stuff that the group needed. And I think that was one of the most remarkable things for me, is we had this motto that, all the code is available to everybody, but if you touch it, you own it. And so what this did was cut down an incredible amount of whining, maybe is the best way to describe it, about this or that feature that wasn't there. It cut off all of those. And the good news about that is that there are certain things that I know both Mike Lesk and I had the experience of coming up with a wonderful piece of syntax and an absolutely appalling implementation, because we didn't really know how to implement it, and only to find that somebody within 2 weeks had, just cleaned it up remarkably. In my case, it was the @ program, so that you could say at 5 a.m. and then just put a command line out there, and at 5 a.m. the machine would run it. And it was great. And then Dennis, I don't think I owned that program for more than a week. And Dennis came in and made sure that the set UID bit was set properly and it was in the right directory and all this other stuff that I didn't even know enough to know I wasn't doing. And time again, that happened. And it was incredibly fertile, and I could see it happening in all kinds of diverse groups, in all kinds of diverse ways. So.
Yeah, I suspect Marcus wants us to move on. Steve speaks to the community, and that's just an example of the sort of thing that Jon mentioned earlier, the fact that people worked on each other's code, improved it. It was a very open thing, perhaps a precursor of what we see with open source, but all done in a fairly small geographical area. So it was a great time. Marcus, should we be taking questions or what?
Yeah, let's do that. And I have to apologize a little bit to rush in here. Our operations teams put me in charge of time because they thought me as a German would be good. What they overlooked is I had been with Bell Labs for 21 years, so I don't ignore rules as well. But I think we have time for 1 or 2 questions maybe from the audience for our panel. So any questions? We have folks, please wait for the microphones. That's over there.
To what extent did working at 110 baud have to do with the rather terse command names and others famously telegraphic syntax?
Geez, Jon, that's a good question. So for the benefit of who might not have heard it, early Unix terminals were very, very slow. Model 37 or Model 33 teletypes were 10 characters per second. It's hard to imagine, and they printed on paper. And that meant that they didn't print very fast. That meant you didn't want them to print very much. The other thing is they were physically hard to type on. It was kind of a bodybuilder's exercise to type. And so you didn't want to have to type too much. So Ken is not here to defend himself. I will say that perhaps the brevity of Unix command names and other things is because of that, but I'm making it up.
I'd second that. It's typing. It's not the speed that the computer can print faster than I can type. So I'm happy only to type 2 characters.
Yeah, I would say on that note, the biggest improvement in computer usability was going from 300 baud to 1200 baud, because at that point it could type faster than you could read.
All right, do we have one more question? All right. Okay, yeah, go ahead, Barbie. Go.
So I work in machine learning research, and I see a number of parallels with the infrastructure that machine learning is kind of developing now with kind of the development of the Unix operating system, where you have this overlap of industry, academia, private, et cetera, in a community-driven environment. And as machine learning kind of infrastructure matures, TensorFlow, PyTorch, the cloud systems, et cetera, I'm wondering if you have any lessons from the development of Unix that you would like to pass on that we should all keep in mind as this sort of monolith or megalith of data science, machine learning infrastructure continues to build. Thank you.
I have an opinion.
Go ahead.
You said a bad word. You said monolith, and I think that's the thing you want to avoid. I think that.
I would say that that machine learning does not produce simple models. By and large, it's aimed at looking at complex things, finding a complex model that its creators can't understand, and that's diametrically opposed to what happened in the early days of Unix, which was to see the simple and general things that underlay or completely replaced the need for the remarkable efflorescence of features in previous operating systems.
I've been working in the field of machine learning for the last 5 years, and what converted me, because I had nothing but contempt for AI for a large part of my career, mainly because it was sort of contemptible, but there is a Google, YouTube that shows a program that they wrote, an AI program to play Nintendo games. And they show the program in 4 hours, just being given the screen, pixels, and knowing that there is something you can move back and forth, and being told to score periodically. And it learned in 4 hours to be better than any human player. And that's what gave me religion in that sense, that we don't all go around doing things as simple as playing Nintendo games, but if you think about putting together a programming team that would have to worry about angle of incidence and angle of reflection and all this other kind of stuff, not to mention just making sense of the pixels, you're probably talking 6 months of effort with programmers. That was a wake-up call.
All right, thank you very much. So I'm already in deep trouble with our timekeepers, but a huge round of applause for the panel. And if you please wait here for a little bit, I want to invite Marcus back up.
Okay, I said I'd be back for